Okay, so review C, third day review, 1, 16, 19, review C. All right, so first of all, we're going to graph number 1. I'm going to do number 1 on graph here, okay? So I'm going to need a graph. I'm going to go slowly. Y equals the square root of x plus 2 minus 3, okay? Everybody got that? Now, what I want to do first of all is graph the parent function. Okay, so I'm going to start here, get my xy axis going. All right. All right, so the normal square root graph, y equals plain old square root of x, is kind of like a sideways parabola, okay? Kind of sideways parabola. And the way I'm going to do that original is I'll start at 0. And I'll do square root numbers. Square root of 0 is 0. I'll go over 1. The square root of 1 is 1. I'm going to go to 4. 1, 2, 3, 4, because there's a square root of 4, and that's 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. The square root of 9 is 3. Now there's other numbers in between, and those are going to be decimal type of numbers, so I'm not going to do those. I'm just going to draw my curve in, okay? So my graph, this is the parent function. This is what it looks like. There are no negative values because you can't take the square root of a negative value, okay? So this is the graph. That's the parent graph. What we're going to do is move it. We're going to move it. So we want to move it to the left 2 and down 3. To the left 2 and down 3. Because we do the opposite on the inside, right? So, let's take this here. Hi, Bella.
Hi.
Here is this, and if you need graph paper, here's graph paper. Don't pass it, Bella. So, let's take this graph and let's move it back 2 and down 3. So just took the end point, 2, 3, and I'm going to do the exact same graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's going to look something like that, okay? All right, that's my square root graph. Now, so I move the whole graph back 2, down 1. Here's my y equals the square root of x plus 2 minus 3, okay? How am I doing? We're going slowly enough? I'm off by a little bit. Should have gone through there.
Oops.
So, domain. Domain deals with the x values, right? So this graph starts at -2 for its x value, right? Mm-hmm. And then moves forward, right? It doesn't have anything behind it, so the domain is just simply x is greater than or equal to -2, okay? The range is all possible y values. Starts at a height of -3 and goes up. So it's just y is greater than or equal to -3. There's my domain and my range for that graph. Okay, guys ready for number 2? Everybody have that? Okay, number 2. And Valley, you can borrow some of my stuff when we get there, okay? You guys want to? All right, number 2. Let's look at number 2. Oh, I got the wrong key. I'm going to borrow yours since I can't find mine, okay? Okay, number 2. We want to find the 42nd term of 2, 7, 12, 17, 22, ... Okay, now these are actually pretty easy. What we need to do, though, is have a formula. Oh, here you go. Can you get there much? I just need a formula. So the formula I'm going to use is this. My formula is A of n equals A1 plus n minus 1 times d. Okay, so let's figure out what all these things are. Okay, in this example, n is going to be 42 because we want the 42nd term. N is always the number of terms. A1 is going to be 2 because it's my first term. And D is the difference between each term, which is 5. It goes up 5, up 5, up 5, so D is 5. Okay, now it's easy. I'm just going to plug in the numbers into the spot. So I need A of 42, because I need the 42nd term. It's going to equal 2 plus my 42 minus 1 times 5. And I'm just going to use my calculator to get an answer. Okay, so I'm just going to plug that in. All right, I'm going to go 2 plus parentheses 42 minus 1 times 5, and I get an answer of 207. Okay. How am I doing? Number 3. Am I going slowly enough? Yeah. Okay, 3. I want to make sure I go slowly enough. Okay, so now what is the sum of the first 42 terms? So now we want to find the sum of this 2 plus 7 plus 12 plus 17 plus dot 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 plus we actually know the last term. We just found it. I know it goes plus 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 plus, but if we want the first 42, we already know the last term is 207. Does that make sense? I'm going to keep adding. I don't want to add the first 42 terms. I already know the 42nd term is 207, so I just plug that in. So again, we need a formula. Here's our formula, okay? S of n, write this down, equals n times a1 plus an divided by 2, okay? I'm going to highlight my formula so I have them, okay? This formula here for arithmetic, this is arithmetic also, okay? So I'm going to write that in there. So I've got it, arithmetic, and this one's arithmetic also. Arithmetic, okay? How am I doing? So, yeah, because there's going to be other forms if it's geometric, and I'll give those to you, okay? Yep. So let's do this. So first of all, I know n. In this example, n is 42, because there's 42 terms. A1, which is the first term, I know that. That's 2. And a of n, which is the last term, I know that. I know a of 42. I know a of n is 207. I just found that one, right? That's the last term. Okay, so let's plug things in where they go. So I need the sum. So I'm going to go S of 42. So it's saying the question, what's the sum of the first 42 terms? Is equal to n, which is the number of terms, which is 42, a1, which is the first term, which is 2, plus an, which is my last term, which is 207, divided by 2. Okay, so I'm just going to use my calculator. All right, I can do that clear. 42 times 2 plus 207 divided by 2, and I get an answer of 4,389. 4,389. How am I doing? Okay? Am I going slowly enough? Okay, 3. I want to do 1/2, comma 1, 2, number 3, 4, 4, yeah, thank you, 4, 8, dot, dot, dot. Okay, Nikolai, you asked a really good question. Do you see the difference? This one's timesing, isn't it? This one's timesing. So this one's geometric, okay? So this one's geometric. So if it's geometric, we just need a geometric formula. So we need this formula. We need a of n equals a1 times r to the n minus 1 power. Okay, that's the formula I need. I'm going to highlight that. I'm going to make sure that's in my notes for tomorrow. Then I'm good to go. Okay? Yeah. This is geometric. So a1 is my first term. That's 1/2. R is the multiplier, the ratio. So I'm multiplying by 2, aren't I? So first of all, a1, that's easy. a1 is 1/2. R is the multiplier, which is 2. Okay? And n is the number of terms. How many terms do I need? What does it say? 15. I need 15. So n is 15. because I need 15 terms. Okay, let's plug it in. Plug, chug, use the calculator, we got it. Okay, so we need a of 15, which is our 15th term. A of 15 equals A1, which is 1/2, R, which is 2 to the 15 minus 1 power, which in my calculator, I'm just going to make that 14, right? Let's make that 14 so clear. Go 0.5 for 1/2 times 2 to the 14th power, right? There's my 1/2, 0.5, right? 2 to the 14th power, boom, 8,192, okay? 8,192. How am I doing? Okay. All right. Return the page. Well, my page. Okay, number 5. Okay, 5 is the sum. That's what this means. N equals 1 to 15 of 1/2 times 2 to the n minus 1 power. Okay, what does this mean? This means to add them up. This means sum, okay? So this thing here means sum, which means add them all up. We'll add what up? Well, let's make some terms, okay? So let's make up A1. So A1 would be, let's see, the first term. That's 1/2, 2 to the 1 minus 1 power, right? Because I plug in 1 to make the first term. Okay, and let's make it. So anything 2 to the 0 power, so A1 is 1/2, okay? Let's make the second term. A2 is 1/2, 2 to the 2 minus 1. So to make the second term, plug in 2. Well, that turns out to be 1. You can use your calculator, you just have to believe me. A3, 1/2 times 2 to the 3 minus 1. Turns out to be 2. I think it's this exact same one we just did, isn't it? It's the exact same one, isn't it? It's the exact same one? So it really is this, let's see, 1/2 plus 1 plus 2 plus 4 plus 8 plus dot 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 plus my last term, right? So what's our formula? We need a formula. So our formula is this. It is S of n equals A1 parentheses 1 minus R to the n power parentheses divided by parentheses 1 minus R, okay? If it's geometric, and this is geometric, this is our formula, okay? I'm going to highlight that, okay? It's a geometric sum. Okay, got it? So, let's see. I know A1 is 1/2. I know R is 2, isn't it? R is equal to 2 because I'm times it by 2 all the way through. Okay, so now I'm going to use my formula, okay? S of 15, right? Because there's 15 terms. Equals A1, which is 1/2, times 1 minus R, which is 2, to the n power, which is my 15, parentheses, divided by parentheses 1 minus 2. And I'll let you catch up. So I'm just plugging the numbers into the formula. That's all I'm doing. And I'm going to use my calculator as soon as you're ready, okay? I'll wait for you. All right, so I'm going to go 0.5 for 1/2. Same thing, parentheses. 1 minus 2 to the 15th power. Parentheses, don't forget your parentheses, right? Divided by parentheses 1 minus 2. 16,383.5. 16,383.5 is the sum. How am I doing, okay? Are you ready for 6? Am I going too fast or am I doing okay? Slide it up for 6. Okay, 6. We're going to have the sum, n equals 1 to 18 of 3n plus 5. Okay, so it does mean sum, means add them all up, okay? It really does. Sum means add them all up, add up the first 18. Okay, we're going to add up the first 18, but I don't know what to add, so let's make some terms. So I'm going to make some terms, find out what's going on. So let's, first of all, A1. A1 is, let's see, 3 times 1 plus 5, which is 8, right? Plug in 1. A2, let's find out, A2 is 3 times 2 plus 5, which is 11, right? Let's make a third term. I don't want to make them all. I'm looking for a pattern, really. 3 times 3 plus 5, which is 14. Do you see a pattern yet? Okay, so really, yeah, Ben's right. So what I'm looking at is this. I'm looking at, it seems like it's 8 plus 11 plus 14 plus dot 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 plus until what? Well, what's the last term I'd add?
18.
It would be the 18th term. Let's make the 18th term. How do we make the 18th term? I do a of 18, right?
Yeah.
So a of 18 is 3 times 18 plus 5. Is that 57, I think? 57, 3 times 18 plus 5. 59. Phew, 59. Okay, so the last term I'd add, plus, would be 59. Okay? Now, we have a formula. We do. Is this arithmetic or geometric? Is this arithmetic or geometric? Am I adding or multiplying? Am I adding or multiplying? Yeah, I'm adding. So it's arithmetic. So this one's definitely arithmetic. So, hey, I just did one of those over here. I did an arithmetic sum over here, right? So let's use this formula, okay? I did an arithmetic one here, right? That's my arithmetic one. Instead of 2 plus 7 plus 12 plus 17, it's really 8 plus 11 plus 14. So that formula is my S of n equals n a1 plus an divided by 2, okay? All right, so I know that n is 18. 18 terms. I know A1 is 8, and A18th, which is the last term, is 59, okay? So I'm going to use the formula. I know the number of terms is 18, first term's 8, last term's 59, divided by 2. Okay, so let's just check it out. Okay, S of 18, because I want the sum of the first 8 terms, equals n, which is the number of terms, 18, times A1, which is 8, plus the last term, A18, which is 59, divided by 2, and I'm just going to use my calculator. 18 parentheses, 8 plus 59 divided by 2, and I get an answer of 603. Okay. Oh, there, we're getting close, aren't we? Next 3 are super easy. Okay, let's whisk this away. We got it? Michael, you good? Lauren, you good? I'll wait for you. Yeah? Just add exponents, right? Just add exponents, okay? Okay, you guys ready? Let's take a look at number 7 on the back, okay? 7. 7a, I've got e to the 4 times e to the 5. We're going to add exponents, okay? So what we're going to do, answer e to the 9th. Easy peasy lemon squeezy, right?
Why do people on this one so bad?
I don't know. I'm a weirdo. Okay. B, e to the negative 2 times e to the 10. Add exponents. E to the 7, right? Nope, 8. I can't add 8. There you go. It's easy if you can add, right? C, 18 e to the 15th over 6e to the 5th. So first, let's reduce. Okay, let's reduce this fraction there. Okay, let's just reduce that. And then we'll subtract exponents. Okay, we're going to subtract exponents. So we're going to get an answer of 3 over 1. You don't need the 1, but there it is anyway. You don't need the 1, but 3 over 1. And then I'm going to get an e to the 10th. Just subtract exponents, okay? Because 5 of these e's will cancel 5 of these e's, and you just have a 10 left over, okay? Thumbs up, you like that, don't you? That was pretty easy, right?
Oh.
All right, 8. I need my graph paper back, okay? Number 8. Let's get my graph paper back out. Okay, oh, this one's a pretty easy one, though. Okay, I got y equals x plus 2 squared minus 4. Okay, now, first of all, I know it's a parabola. You guys agree? It's got to be a parabola because of the x squared, okay? The vertex of this parabola, the vertex, is at -2, -4, right? And the line of symmetry is at x equals -2, okay? I just got it from vertex form, okay? It's in vertex form, okay? So vertex -2, -4. So let me go ahead and draw my xy axis. I'm going to do that right now. Draw my xy axis.
Oh, can you move it further?
I can. How about right there, Katie? There you go. Perfect. Okay, so I'm going to go ahead and put my xy axis in. Okay. All right, let's see what I know. Okay, so let's see. Vertex, right? Vertex is at -2, -4. There's my vertex. I've got a line of symmetry. Goes right through the middle, okay? Right? Now, here's what I know. X squared, right? X squared. This is actually the opposite of the square root graph. So if I go over 1, 1 squared is 1. If I go over 2, 2 squared is 4. If I go 3, 3 squared is 9. Remember doing that? Mm-hmm. Remember doing that? Okay, watch. I'll show you, okay? So from the vertex, Lauren, watch real carefully, okay? Because you'll totally get it. We've done this before. So right here, the vertex, if I move over 1 on the x, 1 squared is 1 on the y. If I go back to the vertex and I move over 1, 2, 2 squared is 4. 1, 2, 3, 4. If I go back to the vertex and I go over 1, 2, 3 for the x, 3 squared is 9, so on the y it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, because I have a line of symmetry, I'm going to reflect my points over the line of symmetry, right? So I have a point here reflected, a point here reflected, and a point here reflected. I'm just going to draw it in. Got it. Not too bad? That's pretty easy, isn't it? Okay. I'll wait for you, and then we'll do number 9. Okay, ready for 9? Okay, number 9. Ben, here we go. Number 9. We have cube root 27 x to the 7th, 27, over 125 x to the 4th. Okay? So what I want to do is this. I want to break it up into 2 separate problems. I want to make it into a cube root of 27x to the 7th over a cube root of 125x to the 4th. Okay? We'll break it up into 2 parts. Top part, bottom part. Numerator, denominator. Slip in some fancy words, huh? Numerator, denominator. Mm-hmm. Every now and then. Nobody knows the math words except for maybe me. Okay, so what do we do? Well, I know that 27 is a perfect cube root, right?
Yep. 3.
So it's 3. So I know I'm going to go 3, but I want to take 1/3 of my exponent. I'm going to take 1/3 of my exponent. I can't take 1/3 of 7 without having a problem in getting fractions. So I'm going to rewrite this as the cube root of x to the 6th times the cube root of x. Okay? I can take 1/3 of 6. That's why I did it. I want to make this into a 6 and a 1 because I can take the a third, I can divide that by 3, right? Over 125 is a perfect cube root. It really is. 5. Okay, 5. And same thing, I can't divide this by 3, but I could divide 3 by 3, right? 3 by 3. So I'm going to make this the cube root of x3, cube root of x. Let me make it x1, okay? So real quickly, before I go any further, Lauren, that's still x to the 7th, right? There's my x to the 7th, right? But I broke it up because I can take a third of that. That's still an x to the 4th, but I did that on purpose because I can take a third of that. Now, do you see anything right off the bat? Do you see anything right off the bat?
You can cancel.
Yep. You guys agree? That cancels that. Totally right. Yep.
Oh my God.
Thank you, Cooper. Thank you, Bruce. You guys agree with that? Totally agree. So let's see what we got. I've got a 5 times x squared. X squared. X squared over, 3. My bad. 3 over 5x to the 1. Okay, 5x to the 1. Now, I got one more thing I could do. Guys, see anything else I could do?
Nope.
Right there.
Yeah.
Cancel an x, right?
Nope.
So I have a 3x over 5. There we go.
It's long. What if we don't complete the paper in the one?
Well, I guess we always have Friday to finish
We
it.
have
Oh,
one.
Lauren, I'm so sorry. Get an hour and a half, right?
Oh, yeah.
Yeah, when I took it, and I'm not saying anything, I'm just saying I took it, I timed it 12 minutes. But I take my time and normally multiply it by 3, okay? So if it took me 12 minutes, you should be able to get it done.
And how many
Completed the
problems
paper
are
in
there?
12 minutes?
Yes,
How many problems are there?
36. And I even took my time.
Yeah, we completed the paper.
Okay, turn it. All right, let's see here. 10. We've got, I have 3 over 2 plus the square root of 3. Okay, now, there's a rule of math. Okay, Ben, there's a rule of math. You can't have a square root in the denominator, can you? So, I'm going to multiply it top and bottom by the conjugate. What is the conjugate? It is 2 minus the square root of 3. The conjugate is the opposite of that. The reason we do the opposite is because you'll see the middle terms will cancel. 2 minus the square root of 3. Okay, got it? Top and bottom by the conjugate. Let's see what happens. Okay, so in the numerator, or the top, I'll distribute. I get 6 minus 3 square root of 3, okay? That's 3 times 2 and 3 times square root of 3, okay? In the denominator, we're going to FOIL. I get a 4 minus 2 square root of 3 plus 2 square root of 3 minus the square root of 9, okay? So I've distributed the top, and then I FOIL the bottom. Now the reason you do the conjugate, the reason for the opposites is it makes these two terms cancel. You get one becomes a plus, the other becomes minus. That's why you do the conjugate. It makes these opposites that cancel each other out. Okay, now let's see what we got. So I got a 6 minus 3 square root of 3, right, over 4 minus 3, because square root of 9. Square root of 9 is 3. Square root of 9 is 3. And then finally, I just get 6 minus 3 square root of 3 over 1. You don't really need the 1. You don't need the 1, but there it is, okay? Wouldn't be wrong if you left the 1, but you don't need the 1, right? All right, to do 11. 11 can be easy if you know some special. Can be if you write these numbers down. 11. So I got 4 over the cube root of 3. So we need to make one of these numbers perfect. Write these down. Perfect cubes. 8, 27, 64, 125, 216, so forth and so on. Okay? We need to make one of these numbers on the bottom. Because if we can make one of these numbers on the bottom, it has a cube root. I'll say it again. We want to make one of these numbers here in the denominator because then we'd have a perfect cube root and we'd get rid of it. Okay?
Let's make 125.
How about we make it 27?
27.
We can make 125.
Well, not really, because then we wouldn't have perfect cube root. 3 times what is going to make me 27? 3 times what makes 27? 9.
I can't.
But that's...
So if I multiply by the cube root of 9, I'd get the cube root of 27, wouldn't I? So multiply top and bottom by the cube root of 9. Let's see what we get. So I'm going to get on the bottom, denominator, I'll get cube root of 27. I like that because cube root of 27 is just plain old 3. Okay, the root's gone. On the top, though, we still have a 4 times the cube root of 9, but that's okay. You can have a root on the top but not on the bottom. You can have a root on the numerator but not the denominator. So 4 times the cube root of 9 is the answer, okay?
What happens if I fail?
You won't.
What happens if you use cube root of 3
Huh?
instead of cube root of 9?
No, it's got because you wouldn't work because you'd get the cube root of 9 and there is no cube root of 9. You got to make, seriously, you got to make one of these numbers. You have to make one of these numbers in the bottom. These are your perfect cube roots. You've got to be able to make one of these numbers on the bottom, okay? You have to make one of these numbers on your bottom, and I did, didn't I? And the cube root of 27 is 3. Does that make sense? Okay. All right, number 12. We're almost there, right? Number 12. Almost there. Here comes the easy one. 12. We've got 4 square roots of 8 plus 6 square roots of 50. Okay, now, you cannot add them unless they're the same. Let's make them the same. Okay, so 8 is the same thing as 4 square root of 4, square root of 2, right? Square root of 8 is the same thing as square root of 4 times square root of 2. 50 can be the square root of 25 times the square root of 2, okay? So break them up. Break them up into perfect square roots, okay? Now, square root of 4 is 2. 4 times 2 times the square root of 2 plus 6 times 5 square root of 2, okay? 8 square root of 2 plus 30 square root of 2, right? Now you can add them. 38 square root of 2. You can do that tomorrow. You can do that one. Okay, almost done. 3x squared equals 75. Okay, easiest problem on the test, right here.
You keep saying that too.
Okay, what do you think? Okay, first of all, how many answers? How many answers?
2.
2, everybody agree? 2 answers? Okay, what do you think we should do first?
We should just take 3 on the other side.
Divide by 3, right? Divide by 3. X squared equals 25, right? Square root. Square root. How many answers?
2.
2x is equal to plus or minus 5. Right? That one's easy, huh? Last one. 14. I have x plus 2 squared equals 25. How many answers? 2. Okay, so, you ready? Yeah, Cody? Square root, what, 13? Yeah, I'm going to. Yeah, you're right. So Cody said square root. You guys agree?
Yes.
So now that means I'd have a x plus 2 equals plus or minus 5. Now, so here's the deal. 2 answers, 2 equations. So to get 2 answers, we need 2 equations. First equation is simply x plus 2 equals 5, and the other x plus 2 equals negative 5, right? That's easy. Minus 2, x equals 3, minus 2 minus 2x equals negative 7. Okay, that is it.